Assalamualaikum. So we will continue on the next method, techniques of integration, which is tabular method. Okay, so for this method, I split the topic into two parts. Okay, right. So let's begin. So as a recap, so we have four techniques of integration. Okay, we have discussed two before. Okay, which are integration by substitution and integration by parts. So now I'm going to explain an integration by using tabular method. Okay, so actually tabular method is something similar, or actually it comes from the integration by parts. The difference is we put the things that we need to differentiate and integrate in tabular form. Okay, which means that we put in table. All right. Okay, so at the end of this topic, you should be able to evaluate integrals by using tabular method. So the evaluation of integrals of the form, for example, x squared exponent ax, x to the power of n times exponent ax, exponent to the power of n sine ax, and exponent x to the power of n cos ax dx. Okay, so if you see from this function, okay, or the integration, so all are combinations, okay, within two different types of functions, okay, which the first functions or the first integration is the polynomial and also the exponential. Okay, alright. So for this kind of equation, so it's actually, if you use you can use integration by parts, but it needs repeated integration and differentiation, which means that not first round only, okay, the integration by parts, but you need to repeat it, okay, especially when n is greater than 1, right? So the calculations are quite tedious and the steps are complicated, right? So we can get over this by using tabular method, which is a special case of integration by parts. So as I said before, so it's actually comes from integration by parts, and still use LOPET, if you still remember LOPET. Okay, so where we have the ln, polynomial, exponential, and trigonometric function. Okay, so next, okay, in tabular method, we shall solve using integrate u v prime dx, where dv equal to v prime dx. Okay, for this to be feasible, the integrals must satisfy the following conditions. Okay, a, u can be differentiated repeatedly with respect to x until becoming 0. Okay, so for the first condition, we have if you have exponential function, for example, exponent 2x, can you differentiate that function repeatedly, or if you differentiate until nth order, okay, first order, second order, third derivative, so you still cannot get 0. Okay, so normally we don't choose exponent 2x as u. Okay, and v prime can be integrated repeatedly with respect to x easily. Okay, so normally we choose something, the functions to integrate, something that can be integrated easily. Okay, so actually these two, okay, can be simplified again as LOPET. Okay, if you still remember, if you use integration by parts, the function that comes first, we will choose as u. Okay, same as this method. Okay, but we don't take it as u. Okay, but it's something that you need to differentiate. So let's look at the example. Okay, evaluate the following integrals using the tabular method. Okay, so we have functions x cubed exponent to x. Okay, where we have what? X cubed is polynomial. Okay, and we have what? We have exponent to x is exponential function. Okay, so we have different functions here. Okay, if you want to use, if you use low pad, okay, so which one will come first? Okay, P will come first. So we will take polynomial, okay, as something to differentiate. Okay, and meanwhile the exponential is something to integrate. Okay, so here you will have this one, okay, u, that's something that you can differentiate repeatedly. Okay, so since we use Laupet just now, so we will choose x cubed as u. Okay, and then the other one, which is exponent to x, so this one. Okay, so this is something to differentiate. Normally I just put differentiate. This one is integrate. Okay, so this is table, so I just put this one, table. Okay, we have 3 columns. Okay, first column is the sign, second column is the functions that we differentiate, and the last column is function that we integrate. Okay, so we start with second column first, differentiate. So we have the function x cubed. So what you need to do is to differentiate, since this is the column for differentiate. Okay, so differentiate x cubed, so you will get 3x squared. Okay, so this is just a direct differentiation. Okay, next, okay, this column is to integrate. Okay, so integrate exponent to x, so you will get exponent to x over 2. Okay, so the first what we call that, first iteration, we still have the second column as a function. Okay, what you need to do is you need to differentiate again. Okay, this 2x squared, differentiate again with respect to x, and you need to differentiate repeatedly until you get 0. Okay, if you get 0, then you can stop the iteration. Okay, so you will, for the last column, you will integrate the function, okay, the previous functions, with the same numbers of iteration as differentiation. Okay, so which means that just now we have integrate exponent to x, and you will get exponent to x over 2. Next is integrate exponent to x over 2, so you will get exponent to x over 4. Okay, I just write here. So if you have exponent x over 2 dx, so actually you can bring what, 1 over 2 exponent x, sorry, this one is 2, exponent to x dx. So this one you will get what, 1 over 2, and then integrate exponent to x, so you'll get the same powers, but like this. Okay, no need to put the plus c at the back. Okay, so you will have 1 over 4 exponent to x for this one. Okay, and you proceed with the same procedure. Okay, integrate exponent to x over 4, you will get exponent to x over 8. Okay, and then integrate again. Okay, you will get exponent to x over 16. Okay, so when you have done up to 0 here, okay, you stop there. So you put the sign, okay, positive, negative, positive, negative, positive. Okay, up to the last row. Okay, Alright, so this is the table. Okay, what you need to do is to get the answer. Okay, after this you don't have to integrate or differentiate anymore, but you can have a multiplication. Okay, you need to cross it, x cubed times exponent to x over 2, and we have the positive sign. Okay, and then 3x squared multiply with exponent to x over 4, and the sign is negative. Alright, and all this you just put as a final answer. Okay, alright, if you look at here, just drop this one. Okay, so the first one, you have what? You have this one. So if you multiply that, so that's why you will get this one. 1 over 2 x cubed exponent to x. Okay, and then next, okay, we have this one. Okay, so you will have negative 3 over 4 x squared exponent to x. Okay, and same for the third row. Okay, we have 6x times exponent to x over 8. Okay, so you can simplify it as 3 over 4 actually. Okay, 3 over 4 x exponent to x. And the last one is minus 6 over 16 exponent to x. Right? And since this is indefinite integral, so you will need to put plus c at the back. Okay, alright, so this is the techniques of tabular method. Right, so we'll solve a few examples on the second part later. Alright, okay, see you later. Thanks.